So in this lecture, I want to talk about the use of the microscope in terms of the objectives and how to always keep a sample both in focus and in the center of view. So I want to start by talking about 4 different objectives and various characteristics that apply to each of these 4 objectives. Okay, so the various characteristics I want to talk about relating to these different objectives include field of view, resolution, the focus knob that we use with each of them, and the depth of focus. And we'll talk about each of these. Okay, so as we move from 4x to 100x, we increase magnification. Now, field of view is how much of the surface area of the slide you can see using each of these objectives. So the objective that has the greatest field of view, that is, lets you see the most of the surface area of the slide, or the greatest surface area of the slide, is going to be the 4x objective. Greatest. While the 100x is going to have the least field of view. So from least to greatest, just draw like this. Least to greatest. Okay. Resolution is the amount of detail you can see in your sample. So the higher you go in magnification, the better the resolution of your particular sample. So 4x in this case is going to have the least amount of resolution, while 100x will have the greatest. Okay. Which now brings us to the focus knob that we're going to use with each. So 4x should always be used in conjunction with the coarse focus knob. Whenever you place a sample on the microscope, you should always start by placing your objective lens at 4x and using the coarse focus adjustment knob to bring your sample into focus. Always, always, always start with 4x and coarse. I can't stress that enough. If you go up in magnification too soon, you're not going to be able to find anything. And if you attempt to adjust your focus using the fine focus adjustment knob when you're at 4x, you're also not going to be able to bring your sample into focus. So, as soon as you place that slide onto the stage, use the 4x in conjunction with the coarse focus adjustment knob to bring that sample into focus. Okay? Once you move up to 10x magnification, okay, the 10x objective, you're going to use the fine focus adjustment knob. Okay? These microscopes are called parafocal, which means as you switch from one objective lens to the other, if you focused it initially, your slide is going to remain relatively in focus, and you only need to make fine or small adjustments to focus your sample. So you'll use fine. So everything after 4x, you should be using the fine focus adjustment knob. So I use it for 40, and I'll also use it for the 100x objective. Now, depth of focus refers to how much you can move through the slide and remain in focus. So the adjustments you can make to focus while still retaining focus. Okay? In other words, if you think about it, your samples aren't sitting flat. They're actually occupying a 3-dimensional space. So there is some area within that space that you can move using the magnifying lens that will still be in focus. But what depth of focus is asking is how great is the upper and lower limit of that focus, where our sample will still remain in focus. And the key to understanding depth of focus is in the focus adjustment knobs that we use. If we're making fine adjustments to focus, it means we have less depth of focus. Okay? And if you think about that, it makes sense, because at 40x, just a slight modification to the fine focus knob can make your sample go completely out of focus. Okay? Whereas with 4x, we're making coarse or really drastic adjustments to bring it into focus. And once it's in focus, if you turn that fine focus adjustment knob, the sample really doesn't go out of focus. So the 4x objective is going to have the greatest depth of focus, while the 100x objective is going to provide us with the least depth of focus. Okay? So that is, how much alteration can you make to the focus knob and still keep your sample in focus? 4x provides us with the greatest amount of wiggle room. We can turn those fine focus adjustment knobs and still remain in focus for the most part on 4x. But at 10, 40, and 100, as we move from objective to objective, that amount starts to decrease. So the depth of focus decreases with magnification.